Hello, my name is Ashley. I'm here to talk about the validation test analysis that I conducted for a study about surface enhanced Raman scattering, otherwise known as SIRS. But I first want to go over the purpose for validating instruments and methods prior to using them. Validation is one of the most crucial processes in using a new analytical technique. You want to verify the analytical procedure's key components is the process of validation, attaining an analysis that is accurate, dependable, entirely within the analysis control, and procedures dependable outcomes is the ultimate objective. Mainly, validation makes it possible to specify a certain analytical process. The best procedure option is made feasible by evaluating the range of accountability for a particular method based on validation criteria to make sure that a certain method and related materials can yield trustworthy results. Validation of forensic DNA typing process is crucial. Next, I want to talk about what the description of surface enhanced Raman scattering is, otherwise known as SIRS. It is a very sensitive method called surface enhanced Raman spectrometry, otherwise known as SIRS, amplifies the Raman scattering of molecules supported by certain nanostructured materials, thanks to chemical augmentation or plasma medicated observation of electrical fields. SIRS enables structural fingerprinting of low concentration. This SIRS offers a wide range of applications in surface and analysis in interface chemistry, catalyst, nanotechnology, biology, biomedicine, food science, environmental studies, and other fields as well, because of its very high sensitivity and selectivity as well. Now, why SIRS? Recent years have seen a significant amount of research on surface enhanced Raman spectrometry, or SIRS, due to its high sensitivity and adaptability. It has been used on a variety of forensic analysis, including paints, textiles, and inks, as well as other components of interest like explosives or narcotics. While there are now several new plasmatotic surfaces that make it possible to get highly repeatable spectra with significant enhancement factors, silver colloids remain the most often used substrates. Colloids provide several benefits over design substrates, including significant improvements, which ease of production and affordability. The purpose of the study that was conducted is that this research examines the method's accuracy in describing the random or precision and sympathic or the biased errors on the observations, the sympathic discrepancy between the measured value and the predicted or the reference value for the chemical of interest is known as a bias. If bias is consistent and sympathic across all measurements, it can be addressed by correcting the data. There are several ways to access accuracy, which may be seen as the spread of subgradient measurements. The first and lowest level, which is sometimes referred to as the methods repeatedly, takes into account within run variability, which is the degree of fluctuation which needs to be minimized. The method for examining the variability, you need to the time dependency of the single intensity, which is the level 1, of the variety of successive SIRS measurements from a single drop made by mixing the chemicals were examined. To take the dynamic nature of SIRS measurements into consideration, a series of measurements were obtained when the target molecules absorb into the silver nanoparticle and nanoparticle aggregates form. The signal typically rises once a steady state is obtained. The signal abruptly declines as the drop dries up. The study of repeatedly has also considered the sample phase, such as pipetting the chemicals. 10 distinct samplings or levels were compared for this purpose to determine the standard deviation. 10 duplicate measurements were made of each of the ensuing levels to determine if they were accurate or not. There were different molecules that were used. 3 forensic probe molecules were utilized in this investigation. One was explosive 2,4,6 trioloptidide, or TNT, stimulant substance methylphenide, or MA, and the color crystal violet, CV. The selection of CV was based on its excellent absorption to silver colloids, stabilized with citrate rate, strong symmetry, and molecular residence at 633 nanometers. Because of its poor absorption on silver, MA, a negatively charged molecule with an amine side chain and phenyl ring, was selected. TNT was selected as an intermittent binding candidate because of its potential for absorption through weaker van der Waals interaction and its benzene ring with 3 nanogroups. The results that were made was that the work shows that since intensity varies time dependently as a result of aggregation and absorption processes, it is an intrinsic feature of SIRS, silver or silver electric scattering measurements. The extra variability related to pipetted chemical volumes introduced by the sampling approach employed with silver colloids repeatedly is the primary cause of variance. For subsequent measures taken under comparable circumstances, the investigation varies that all tests performed with comparable material is in a single laboratory are repeatable in that colloid preparation does not contribute extra variability. SIRS's primary disadvantages are comparable to those of Raman spectrometry that have already been noted. Nonetheless, a high degree of wavelength consistency across various Raman equipment makes it possible to identify components based on the existence of distinctive peaks. The variety of components investigated and their variety characteristics limit how broadly the results may be applied. For worldwide qualitative violation, more research on the technique's sensitivity and resistance are needed to go further. In conclusion, according to the research, SIRS is a trustworthy method for detecting forensic compounds. The interaction between the molecules and the SIRS substrate determines its repeatability and reproductive ability. While molecules with moderate binding have more repeatability but more variety, strong candidates with strong binding and resistances have lower RSD. Molecules with low binding affinity can nonetheless be detected at high enough concentrations. In my eyes, this study was extremely thorough in going through all of the aspects that were performed. The study did a wonderful job at including images that corresponded to each of the aspects that they studied, by including all their graphs and images throughout the study as well. There were no analytical gaps that I observed throughout the whole process. They were very thorough in including all of their disadvantages and advantages, everything that was good about SIRS and everything that wasn't. Overall, the study was very well done and did a fantastic job at explaining each part of the study that occurred. It could have used more. The only thing that it could have done better was that it could have used more on what service enhanced Raman scattering, or SIRS, is actually, and why it was used in their eyes. Thank you so much. This was my presentation on the validation test analysis for SIRS.